Scene one, Apple, take one.
My name is Adiv González. I was born in Oaxaca, Mexico. I'm 33 years. I am an astrophysicist. My hobby is photography, particularly time-lapse photography. I'm working now at the HAWC observatory. HAWC stands for the High-Altitude Water Cherenkov observatory. Well, high altitude because it was built in this mountain called Sierra Negra. It's built at an altitude of 4,100 meters above sea level, so it's very high. It's also water Cherenkov because the detection principle is water tanks where the gamma rays that come from sources that are very, very far away, thousands of millions of light years. And then, while these gamma rays interact with the atmosphere, there is a shower of secondary particles, very energetic particles. And then when these particles hit the ground, so when these particles hit the tanks, they will produce a pulse of light in the water that is called Cherenkov light. We collect with photosensors, we collect this light. And these are very, very high sensitive photosensors, so we can detect even a single photon from this Cherenkov light. The impressive thing, apart from detecting this photon, is that from the photons that we detect from these very high energy gamma rays, we can tell a lot about these sources. From the shape of this spectrum, you can infer how this radiation was produced. It's impressive how with this, let's say, limited information, we can know a lot of something that is really, really far away. The adventure to get there starts from the city itself, getting up really early to avoid the traffic of the city to get out, and then traveling 3-4 hours to the base town, a town that is in the base of the mountain where we sleep. Actually, they have a lot of ships. You can find a lot of ships in the road. Sometimes they took a lot of time to get out of the way. The first thing that you will see will be huge tanks, and I mean huge tanks. These tanks are almost 5 meters high, and with a diameter of 7 meters. So they are really huge, and you will see a lot of them. There are 300 of these tanks, and each tank can hold up to 200,000 liters. So that's a lot of water. You can see them clearly in Google Maps. I've been related to this experiment since 2008. I was there in the site when there was nothing there. Actually, there was no road to the site. We have to walk like a kilometer in the mountain to get to the site, and there was nothing. And I was there from the beginning. I was there when the first prototype of these tanks, steel tanks, were built. And actually, we didn't have much idea how to build these tanks, so we were testing ways to build them. And this first prototype, those were that we have to build by hand, carrying the plates with our own hands and with our strength. And it was really hard working at that altitude. So we have to do some hard work. I mean, carrying these plates and screw them and using ladders to carry them. Really tough because you get out of air really fast. Because, the air up there is thin. Was kind of hard. The best part of all is, particularly when you live in a big city like Mexico City, is to see the stars. Because in the cities it's becoming really hard to see stars. When you are up there with no clouds and you are seeing the stars, well, it's, I don't know, your mind gets full of, inspiring ideas, or you just, it's really incredible to be there. This experiment will expand the knowledge about these gamma ray sources, especially at very high energies. So far, there is no other experiment in the planet that can measure at these very high energies. But I don't know, I would like to think about what we cannot see now. I mean, when these experiments are designed based in detect what we know we can detect. But the exciting part is to observe something that we didn't expect. And I hope after 10 years of taking data, we can find something that we didn't expect. That will be the exciting part.